In this video, I wanted to review just some basics from statistics. Some of this, of course, you've seen before just whenever you've done any sort of statistics in high school or anything like that. But the reason why we're going to review this stuff is because in 5.5, we get into a really cool application of integrals where we can use it to calculate probabilities. And so, of course, having a good foundation of statistics will help us understand that a little bit better. So we're just going to run through some kind of basics here. So here I have a sample of heights. With statistics, you always have a sample of data. And so here are a bunch of heights of NBA players. And what we're going to do is we're going to find these 7 things. Okay, we're going to find range, mean, median, mode, outliers, if there's any of them, variance, and standard deviation. Okay, well, range is just the distance between your smallest and your biggest, right? What's my range in heights? And so all this is your biggest value minus your smallest value. Okay. So in our case, my biggest value is what? 84. That's the tallest NBA player that was sampled. And my shortest NBA player that was sampled was 73 inches tall. And so that gives me a range of 11 inches. Mean. What is mean? Mean is another word for average. Okay? So your mean height is going to be your average height. How do I calculate average height? Well, it's actually right up here. Okay? That's what this is. And if you remember what this symbol means, this symbol is a summation. So I'm summing up all of my different heights. I'm summing them all up and dividing by however many there are. Okay? So I'm going to add up all of my height values. I'm going to add all these up, and I get 936. That's what I get when I add all these together. Okay? And then I'm going to divide by how many NBA players I actually sampled, which ends up being 12. There's 12 of these numbers. Okay. 936 divided by 12 is 78. So my average value, we can notate that with X bar, is 78 inches. That's my average height. What is that? 6'6"? Okay. Very nice. Median. Median is your middle number. You might be thinking, what's the difference between that and average? Middle number is when I actually order the numbers and figure out which number is actually in the middle. Okay. Looks good. So middle number is just where's my middle values here. So what you can do is you can count in from the edges. So I've got my point here, keep on counting in until I actually meet in the middle. Now, if you have an odd number of data points, you'll meet at a single point, and that's your median. But here, since I have an even number of data values, there's 2 middle numbers, 78 and 78. Now, because these numbers are the same, that makes it really easy for us. In our case, my middle number is just 78, which is interesting. It ends up being the same as the average. That's not always going to be the case, but in our case, it is. But if those 2 numbers were different, what would you do? You would just average those 2 middle numbers. Okay? You'd take the average of the middle numbers. Okay. So that's the median. Mode. Mode is the most frequent number. Or value. Value is probably a better word to use since we're talking about data values. Right? So if I look at my data, which values occur the most frequently? Well, we already know that 78 happens twice. So does 80. Both of those numbers occur twice. So those end up being my modes. 78 and 80. Those are both my mode values because they're equally as frequent. Okay. E, outliers. Interesting. So what is an outlier? An outlier is any data value that's abnormally large or abnormally small, okay? Any abnormal, right, not normal data values. Now, so we could, of course, try and make that decision just based off of, what do we think? Is 84 abnormally large? Is 73 abnormally small? It's hard to make a judgment call. So instead, in math, we've come up with an actual mathematical way to determine whether it's a standard deviation or not. Or sorry, whether it's an outlier or not. But in order to do that, we actually need the standard deviation. So this requires my standard deviation, which we'll get to in part G. So let's pause on this one for now and keep going. Let's talk variance. Variance deals with how far is each data value from the mean. That's what variance deals with. And that's actually what standard deviation is about as well. So variance and standard deviation are very, very closely related. Okay? But the idea behind variance and standard deviation is how far is each data value away from the mean. And so we've got these kind of complicated formulas up here. And so I'll try and explain those actually what they mean. But you'll notice I have two different formulas based off of whether I'm looking at the entire population or just a sample of the population. Okay? The reason why the formulas are different is if you have the entire population, there's no other data that you need to worry about. And so you can calculate the variance and the standard deviation just straight, how you normally would. But with a sample, you're recognizing the fact that there's a lot more data than what you're looking at, which means I need to make some, what's the correct word here? Make some allowances for the fact that there could be more data that could skew this. And so you'll notice with the variation for sample, I divide by n minus 1 instead of the total number of numbers, or the total number of data values that I have. Okay, but let's take a look at this. So recall that my mean is 78 inches. Remember, variance and standard deviation are all about what's my distance from the mean. So I need to know my mean. And so now if I look at each of my data values, I'm going to make a table here. Okay. So let's look at each of my data values. I've got 73, 74, 75, 76, 77, 78, another 78, 79, 80, another 80, 82, and 84. What I'm going to want to do with each of these is calculate the distance it is from the mean. How far are each of these away from the mean? Okay. For these numbers less than the mean, from smaller than the mean, you'll notice that I'm going to end up with negative values. This is negative 5 inches away from the mean, which means it's 5 inches less than the mean. Okay. 4 inches less than the mean, 3 inches less than the mean, 2 inches less than the mean, 1 inch less than the mean. For 78, since that's what the mean is, I'm going to put 0. These are 0 inches away from the mean, right? It's exactly on the mean. And then as I get bigger than the mean, I now switch to positive values. So those are my distances away from the mean value. So you'll notice, to calculate variance, what I'm going to do is I'm actually going to square all of those distances and then add them up. Okay? I'm going to square the distances and then add them together, right? That's what that E represents. That fancy E is. It's a summation. So with my table over here, let's actually go ahead and square these values, because I'm going to need to square them before I add them up. Why square them? The reason why we square them is because I don't want to be working with negative values. Now you might you might think, well, why don't we just take the absolute value? Why can't we just turn them positive? And that's because if we want an actual formula, we want to avoid absolute value, because absolute value is a piecewise function, which means it's not as straightforward to include in just a nice formula. Instead, we'll square, because squaring a number will guarantee that you're going to end up with a positive value. Okay? And so last but not least, I'm going to add all of these values up. 116. Sorry, I'm moving into problem number 2 slightly, but I get 116 when I add all of those squared values up. And then what does the rest of my formula say? Now I'm going to divide it by my number of data values, but minus 1. Okay, so to finish this up, right, my variance, we use the term s squared for variance, equals the sum of those squared distances divided by the number of data values minus 1. So 116 over what's 12 minus 1, which is just 11. And that gives me, I do have to round here, but I get approximately 10.55. 10.55. That's my variance. Okay. Well, the reason why we use s squared is because to find the standard deviation, which is our next piece, g, to find standard deviation, you just square root it. Okay. Standard deviation is just the square root of your variance. Okay. And so that's just the square root of 10.55, which is approximately 3.247. Okay. What is the standard deviation? Well, this standard deviation is a little bit easier to understand. This is my average distance away from the mean. So on average, my data values are about 3 inches away from what the mean is. Okay? Standard deviation is a measure of spread. The smaller your standard deviation, the closer together your data is, the more compact your data is. Okay? The bigger your standard deviation is, the more spread out your data is. And so it's a measure of spread. It can tell you how spread out your data is. Okay. Why do we square root? Why is there a square root involved with standard deviation? Because we have to undo the squaring that we did here, right? As part of my variance formula, I squared all my distances to make them positives, so I eventually have to undo that, and that's why that's involved with the square root. Okay. So we've now calculated the standard deviation, so let's go back to part E. Like I said, standard deviation or outliers depend. The mathematical way we determine outliers depends on what your standard deviation is. So if I come back here, your outliers can be determined are any data point more than 2 standard deviations away from the mean. In our data, do we have any data points that are more than 2 standard deviations away from the mean? Well, here's my standard deviation, right? There's my standard deviation. So what would 2 standard deviations be? Well, that's just 2 times 3.247, which is equal to 6.54. No, close. 6.494. So almost 6.5, right? So do I have any data values that are more than 6.5 inches away from the mean? Well, if I come back here and look at this column, remember this column is how far my data values are away from the mean. Are any of those numbers bigger than 6.5
or more negative than negative 6.5? No. All of those are smaller than 6 or bigger than negative 5, right? So that tells me I do not have any outliers. Okay. So since I ran out of room over here, I'll just write that up here. No outliers. Okay. Sounds good. So your assignment for this quote-unquote section, since all we did was just review statistics stuff, all you need to do is just finish problem 2. So you can find this. I will post this sheet on the Canvas page. You can download it, print it out, or just complete this on your own set of paper. Then take a picture of it, upload it as a PDF, and submit it to Canvas. Let me know if you have any questions. And just to help you out, notice which formula am I going to use? Am I going to use my sample formula or my population formula for this problem, for number 2? Well, it's nice because the word sample is right there at the beginning. These data values represent a sample of ACT scores. It would be the entire population if these represented all the ACT scores in, the country, which of course would not be true since we know that more than 9 people took the ACT. So this is just a sample. You're going to be using that same sample formula we used in our problem. Okay, good luck, guys.